Hello. In this video we are going to discuss about another loading conditions in beam, that is uniformly distributed load, as we can see over here. So 10 kilonewton over the span of 4 meters. So let's do it in Ansys, and going for preference, structural, and element type, we are going to select beam 2 nodes, and material properties, material models, structural, linear, elastic, isotropic, and this is gonna be 210 E9 of 210 E9 0.27. Okay, then I'll go for sections. Common sections, and this is given as 0.1, 0.1, preview, okay, replot. And next, for modeling, I'm going to create key points in the active coordinate system. So according to problem, one at 0, one at 4 meter, and another one at 6. Effective CS 1, just apply. Second is at 4 meter, third one is at 6 meter, and click OK. So we have the key points. Now next we are going to create lines, straight line, 1 to 2, 2 to 3. Okay. Next I am going to mesh it. So before meshing I am going to select the size control, manual, lines, all lines, going to divide it into 50 elements each. So it's divided like that, and we'll create a mesh now. So in order to create elements, we create mesh. Okay. Next I'm going for plot controls, plot and lines. So I have divided these two lines over here. Next I'm going to apply the loads, apply displacement, and if we see in the question, these two are constrained in every direction except rotation in z-axis. So displacement on key points 1 and last one, apply. So everything is constrained in x, y, rotation in x, rotation in y, except rotation in z. So click OK. Now the next thing that we are doing is force component. So this is going to be on the key point, so but we don't have any force over here. So this is pressure. We are going for the pressure command on the beams, and we are going to select box because the uniformly distributed load is for whole of this area. So what we are going to do is we are going to select box. We can't go single, so we are going for box, click, drag, and just keep in mind only cover the first element. Zoom in and see how far it has gone. See, only for the first element we have applied. Click on apply, and at value of I, it's actually all constant, so 10 kilonewton we are given. So 10 and 10, we are keeping everything in kilonewton only. So click OK. So this is what we have applied, and don't care about if I just 1 second, if right now I zoom out, the uniformly distributed load that we are applied, which is visually being shown here, will vanish. So don't worry about it. See, but it's actually there. Now next thing what we are going to do is go for solution, current ls solve, and the solution is done. Then I'm going to define the element table, define table, and SMISC3 apply, then SMISC6 apply, then SMISC16 apply, then SMISC19. Okay, so this is what we have done. And 3 and 16 is again for bending moment, whereas 6 and 19, this combination is for shear force diagram. Thus just close this. Now we can do one thing, we can go and plot result, you can go for nodal solution, and for displacement we can go for displacement vector sum, go on apply. This is what we are getting. We can save it using the image capture command over here. Next thing what we are going to do is we can get the stresses that is being generated. So for that we go for nodal solution, and in that we go for stresses and von Mises stress. Yeah, click OK, and this is the value of stress that we are getting. Next thing that we need is line element results, and 3 and 16. So this is what we have, the bending moment diagram. So we have the maximum value as well as minimum value stated over here. For the next one we are going to have 6 and 19, and 6 and 19 again, that's for shear force diagram. Click OK. This is the shear force diagram, and this point is known as the point of contraflexure, where the shear force diagram changes its direction. So again we have minimum as well as maximum shear force stated over here. So that's how we solve this problem. Thank you.